Welcome to CorrMapper, an online research tool for the integration and visualization of multi-omics datasets and clinical metadata. In this video, we will give you a glimpse of how CorrMapper can help you analyze your omics and multi-omics studies, irrespective of what platform you use to acquire the data. So let's get started. First of all, you will need to register with a valid academic email address. Please contact us if your institution's email address was not recognized automatically, or if you would like to be granted non-academic access to CorrMapper. Once you confirmed your email address, you can start uploading your studies straight away. In CorrMapper, each study can have up to 2 omics datasets and a metadata file. At the upload section of the site, you will need to attach these files and answer a few questions about your study. Whenever in doubt, just use the question marks to get more information. For demonstration purposes, we will be using a breast cancer study by Chin et al. From 2006. The authors of this study used both gene expression and copy number aberration assays to stratify a cohort of 130 breast cancer patients. We will select the data files which have gone through platform-specific pre-processing. Additionally, the study also collected a set of clinical metadata variables from these patients. We will attach this metadata file as well, so we can explore it as a dashboard later and also perform feature selection using any of its clinical variables. CorrMapper has a specialized visualization interface for genomic data that provides an excellent high-level overview of such datasets. It overlays genomic features onto the chromosomal map of the studied species and displays it in a circular plot, as we'll see later. For this, we need to tell CorrMapper what species the omics data belongs to and provide annotation files that precisely locate each genomic feature along the chromosomes. Once we uploaded our omics datasets and metadata file, we will be taken to our profile page where we will find all our studies and analyses from our past sessions. Here we see the study that we've just uploaded. By clicking the Explore button, CorrMapper will automatically generate a highly interactive dashboard from our data. This dashboard not only visualizes our metadata variables in a novel and engaging way, but it also maps them onto the lower dimensional representation of the omics datasets. On the left-hand side, the dashboard allows us to filter our cohort of patients in any imaginable way, using the interactive pie and bar charts. These were all built from the uploaded metadata file and can cross-filter each other, which provides a great way to stratify a cohort of patients. On the right-hand side, the 2 omics datasets are presented as scatter plots after they've been projected to a lower dimensional space using PCA. We can select any patient subgroup from these plots, and charts on the left will update accordingly, showing us the distribution of the clinical variables in the selected group. We can also map any of the metadata variables onto these plots to assess how well they can help us with patient stratification. For instance, here we find that once we map the estrogen receptor status onto the first 2 principal components of the gene expression data, we see a clear separation with 2 distinct gene expression subgroups. Let's say that we are curious to know which parts of the genome contribute to this separation. CorrMapper offers several powerful feature selection methods that you can use to answer this question. We will leave the dashboard now, but feel free to go through the help section by clicking on the question mark. This will explain all the features of this interface step by step. To answer the earlier question about the estrogen receptor status, we will go back to the profile page and start a new analysis on the breast cancer study. On the analysis page, we can specify the metadata variable and the algorithm we would like to use for feature selection. Once the important features are identified, CorrMapper will calculate a partial correlation graph between these features with permuted p-values that are corrected for multiple testing. Here we can specify the method and significance level that we would like to use for correction. Since the analysis can take a while, we can leave the site after we've submitted our job to the cluster. CorrMapper will send a notification to our email address once the job has finished. Then, when we return to our profile page, we can either download the results as a zip file or explore the correlation network in 2 highly interactive visualization modules. Following our previous line of interest, we will check the analysis that selected features which are relevant for the estrogen receptor status of the patients. By clicking the Explore button on a completed analysis, we will be taken to the General Network Explorer. This interface displays the correlation network in 3 different ways. The interactive heat map can be used to check the raw data that went into each of the correlations. We can also explore the tightly connected network modules that were identified by CorrMapper. The heat map can be reordered by several criteria using the drop-down menu at the top, or even by individual features. Any combination of correlations could be easily selected to subset the network and make their exploration easier. We can copy these selected features to our clipboard or type in a search term to find a particular feature. On the right-hand side, a bipartite network displays the same information that the heat map holds, but in a different representation. We can zoom in on the network, click its nodes, and see connectivity patterns between features that might not be obvious on the heat map. Finally, this second, ring-like network provides a third view of the results. This egoistic representation will always focus on the selected feature's closest and second closest neighbors. Like the other network, this is fully integrated with the heat map as well. When combined, these three interactive pieces provide a fluid and engaging experience that makes the General Network Explorer a very capable data exploration tool. We don't have time to explore all the features of this visualization module, so make sure you check the help section that will guide you through each of the components step by step. For studies with genomic features, CorrMapper provides another visualization module that is specifically tailored to this kind of data. We ran another analysis choosing familial history as our target variable for feature selection. Let's have a look at the results by opening the Genomic Network Explorer, which could be reached from the menu of the General Network Explorer. On the left, we see a circular chromosomal map of the species the study was carried out on. Since this demonstration is based on the data from breast cancer patients, we see the human genome here laid out in a clockwise fashion. At 12 o'clock, we see the first chromosome, followed by the other autosomes, till we finally get to the X chromosome around 11:30. For visual clarity, CorrMapper bins all genomes into 300 buckets. In case of the human genome, each bucket corresponds to roughly 10,000 kilobases. Most buckets are not displayed here, as there aren't any genomic features in them that were selected to be relevant for familial history. Since the edges run between stretches of genomic regions that are each 10,000 kilobases long, each of these edges can contain multiple correlations. Therefore, this network serves as a high-level overview, while the tables on the right allow users to dig deep and examine individual correlations. The network could be filtered in different ways using these sliders. We can limit our investigation to only a certain range of correlation values, or look at only edges that have several correlations. If we want to explore the individual correlations of the network, we can use the tables on the right. These tables are filled with all the annotation information that we uploaded earlier. There's a separate table for the gene expression data and another one for the copy number aberration data. We can easily navigate between these by using the left and right arrows on our keyboard. By rolling our mouse over the rows of the table, the selected feature gets highlighted in the network. If we click on any of the rows, the table will display the features that are correlated with the selected row. If we now roll our mouse over these features in the subtable, we will see the row data that were used to calculate the correlation. Furthermore, we can easily sort these tables by any of their columns, or search for our favorite gene or biological function using the search bar at the top. The close integration of the interactive tables with the network makes this visualization module a powerful research tool for genomic data. Finally, make sure you check out the help section to learn about the features we didn't have time to cover in this short intro. We hope that this quick tour of CorrMapper piqued your interest and you will be using it soon for your research. Thanks for watching.